G'day guys, I'm just going to do, by request, a bit of a recap on normal distribution. So my previous video was inverse normal distribution, so having been given the probabilities, can we find the values in question? But again, as per requested, we want just a recap of how the normal distribution works. So I've done a really simple example to try and help make it a bit more intuitive. So cars, hopefully you can read it, cars along a stretch of road have an average speed of 90 kilometers per hour and a standard deviation of 10 kilometers per hour. We want to calculate the following questions. I've just made these up. So we want to find the probability that someone travels more than 75 kilometers an hour, and we want the probability that someone travels over 102 kilometers per hour. And then a bit of a trickier one, we want the probability that someone travels more than 97 kilometers an hour, but less than 104. So you could pause and maybe give them a go if you like. Otherwise, I'm going to get started. So probability that someone travels more than 75 kilometers per hour. So what we want is we want to draw a normal distribution. It doesn't have to be pretty. Put your mean, write your standard deviation down, put the value in question, and then shade per the context. So this is the probability that someone travels more than 75. Okay. Well, we know that a standard normal distribution is symmetric around the mean, and we know that 100% probability lies beneath this curve. So we know that on the right hand side of the mean is 50% or 0.5. Okay, so all we have to do is calculate the probability between 75 and 90, which is exactly what the normal distribution table does. You can see by the diagram that we're given, this gives us the probabilities between some number of standard deviations z and the mean. Okay, all we need to figure out though is how many standard deviations away this is. So how many standard deviations of 10 fit into this distance? And this distance is obviously 15. So we're looking at z being 1.5. 1.5 standard deviations. Did you pick up on how I figured out how many that was? I looked at the distance. Okay, so 75 minus 90, and I divided that by how big the standard deviation is, and that gave us negative 1.5, or just 1.5 standard deviations in the left direction. Is there a general formula for that? There is. It is x minus mu over the standard deviation. That is how we find z, the number of standard deviations. Okay, anyway, back to the problem. I know that I'm 1.5 standard deviations away, so I go 1.5, and I'm not going to any other number of decimal points, so 4332. So this probability in here is 4332. Right, I just have to add those probabilities up. So the probability of someone, say x, travelling more than 75 kilometers per hour is the 0.5 plus the probability we found in here using our normal distribution, plus 0.4332. So there's 0.9332. A 93.32% of the cars on the road are travelling, on this particular stretch, travelling more than 75. Okay, hopefully that makes sense. So we'll do the next one a little bit more formally with just using the formula and not trying to use that intuition. So because, well, we'll use both. So question B was the probability that someone travels more than 102 kilometers per hour. And again, it's not really looking like our normal distribution table that we want. we want a tail. So we're going to have to use a bit of that intuition again. So we can use the normal distribution table to find this shaded area in red, because it always gives us the probability from the mean to some number of standard deviations. And then we're just going to have to think, use a bit of problem solving to figure out how we'll get the tail. So we know that the total on this half of the normal distribution is 50%. So we're going to take 50% and we're going to subtract this red area, and that'll leave us that tail. So how many standard deviations away is 102 from 90? Well, hopefully you can just see that because our standard deviation is 10, that's 1.2 standard deviations. But we'll use this formula just to kind of show it. So the number of standard deviations is 102 minus 90. Oh, sorry, it's going to be 2.2, isn't it? Over 10. So 102. No, sorry, yeah, that's 12. Is 12 over 10, which is 1.2. So we look up 1.2 on our standard deviation table. Oh, sorry, our normal distribution table. 1.2 is 3849. Just want to write that down. And so that is the probability of all that red. So the probability of someone driving, what was it, more than 102 is equal to 0.5 minus 0.3849. So I might get my calculator to do that. 0.5 minus 0.3849, 1151. So 11.5% of people on that road are travelling more than 102 kilometres per hour. So hopefully that makes sense. The trickier question now is, I call it the sliver, because we're just wanting this little section in one side of the graph. So the probability that someone travels more than 97 but less than 104. Okay, it's going to be this green probability. So all of that. Take away, again, just like that previous problem, take away this red part, because again, third reminder that this normal distribution table is always taking the probabilities from a mean to a number of standard deviations. So we're going to get the probability that someone travels, we're going to get the probability of someone travelling more than 90 but less than 104, and that's just going to be easily read off the table because it's between a mean and a number in question. So how many standard deviations away is that? Z is 104 minus 90 over 10. Well, that's going to be 14 over 10, 1.4. So this probability is going to be equal to, we've got to find 1.4 in the normal distribution table, 4192. Okay, then we need the probability of someone travelling more than 90 but less than 97. So we're going to have to get the number of standard deviations, 97 minus 90 over 10, or 0.7. And so the probability is going to be at 0.7 standard deviations, 2580. Okay, so we've got the probability that someone travels between 90 and 97, and we've got the probability that someone travels between 90 and 104. We're going to take this 90 to 104, and we're going to subtract the 90 to 97. It's going to leave us the probability that someone is between 97 and 104. So the probability that someone is between 97 or greater than 97, less than 104 is, I'm going to show my working, 0.4192 minus 0.2580. And I'll use a calculator since this is a video. 4192 minus 0.2580, and we get 1612. And to interpret that in the context, 16% of people on this stretch of road are travelling between 97 and 104. Perhaps those are, recommended safe travelling speeds for that area. And we're trying to figure out the number of people who are travelling in that safe zone. Cool. Hopefully that makes sense. Tomorrow's video is going to be about finding unknown means and unknown standard deviations given some information. So that should be quite interesting. Nice.